I'm going to do question 1 part A for bonus. So the question asks us what should be the daily output to obtain the maximum total profit. We have the equation for the cost and the price, and we have x, and we know that x will give us the number of printers per day or the daily output. So we know the equation of C of x, which is equal to 1 over 6x squared plus 35x plus 12, and the equation of the price, this is the equation of the cost, and the equation of the price is 40 minus 1 over 4x. And we need the profit, the equation of the profit, to get the so we know the daily output, so we can obtain the maximum total profit. So the equation of the profit is equal to the revenue minus the cost. So we have the equation of the cost, but we don't have the equation for the revenue. So how can we get the revenue? As we've took in 3.4, that the revenue is equal to x times the price, P of x. So we know the price is here 4 minus 1 over 4 1 over 4 times x. So we can do here r of x is equal to x times 40 minus 1 over 4 times x. We can distribute the x here. R of x is equal to 40x minus 1 over 4x squared. So that's the equation for the revenue. What we're going to do right now is to get the equation of the profit. So profit is equal to revenue minus cost. So the revenue equation, we have it here. 40x minus 1 over 4x squared. 1 over 4, excuse me. The x is up. X squared minus 1 over 6x squared plus 35x plus 12. So now we can distribute. We're going to get, so negative 1 over 6 minus 1 over 4. We're going to get P of x equal to 5 over 12. Negative 5 over 12 x squared plus 40 minus 35 5x minus 12. So minus, so this is the equation for the profit. So now to maximize the profit or optimize the profit by maximizing, we're going to get the derivative. Then after getting the derivative, we're going to let it equal to 0, which is going to give us the critical values. Giving the critical values, we will the critical values is giving us like when the slope is 0. So when the slope is 0, it's either it may be a max or min or even neither. So we need to check if it's a maximum, and we also need to get the domain. So now what we're going to do is get the derivative of the profit. P prime of x, we can, so as we know the rule, move it down, minus 1. So negative 5 over 2 times 2, negative 5 over 12, sorry, excuse me, times 2 is going to give us negative 5 over 6 x, and the derivative of negative 12 is 0, and the derivative of 5x is going to give us 5. So this is the equation of the derivative. We're now going to let the derivative equal to 0. So P prime of x is equal to 0. So 5 over 6 x is equal to 5. So what I did here is let it equal to 0, and I moved the negative 5 over 6x to the other side, so it becomes positive. multiply by 6. 5 times 6 equals 30. 5x equals 30. Divide by 5. Dividing by 5, we're going to get x equals to 6. So when the x equals to 6 is the number of printers per day. So we need to check if it's a maximum by using the first derivative test. And you also need to get the domain. So firstly, I'm going to check if it's let me first get the domain. So x must be greater than or equals to 0, and the price must be greater than or equal to 0, because price can't be negative. So we know x is greater than 0, and the price is equal to 40 minus 1 over 4. X must be greater than 0. So when move it to the other side, so 40 is greater than 1 over 4x times 4. We're going to get x is less than 1 over 60. So domain equals x is between, not equals 0, 0 and 160. So as we have it here, so now we need to check if it's a min or a max or neither. So we're doing the first derivative test. So f prime of a number before 6, which is 5, and a number after 6, which is 7. So we can check here. So using the derivative equation, so which is here negative 5 over 6, so negative 5 over 6 times 5 times 5 plus 5, we're going to get a positive number. So it's increasing 0, and then here f7 we got a negative number, so negative, so it's decreasing. So we have it as it's increasing then decreasing, so we have it as a max. So 6 is correct. So the maximum profit, if we want to check if it's really a maximum profit, we can check the endpoints here, f of 6 and f of 0, f of 160. So f of 0 is going to give us negative 12, profit of negative 12, so we're losing 3 and negative 873. So here, therefore, concluding sentence here, so therefore the daily output must be 6 to obtain a max profit of $3. So that is how we solve question 1 part A. So this is how I solve question 1 part A.